Hello, we're back. So that was where we looked for the velocity, right? Now we're going to look for the mass. So it says a 4-kilogram bowling ball. Notice how it's in kilograms, so we don't need to convert it. And Mr. Sandoval gave you a nice handy dandy little chart that we can fill out. So the mass of the first object was 4 kilograms. And the velocity was 5 meters per second. And notice that it's positive because it's moving to the right. We do not know the mass, the velocity. It says a stationary pin. Stationary means it's not moving. It would be 0. After the collision, the mass of the first object stays the same. The velocity after the collision is 4.5 meters per second. The velocity of the pin is 3.2 meters per second. And we're looking for the mass of the pin. So you could do this two ways. You could do it with the chart. So we know that mass times velocity equals momentum. So 4 times 5 is 20. Blank times 0, anything times 0 is 0, right? And we know that we have to add the momentums to get the total momentum. So 20 plus 0 is 20. And we know that the total momentum at the beginning needs to be the same as the total momentum at the end because of the law of conservation of momentum. Which again says that the total initial momentum is equal to the total final momentum. So these need to be the same number. So because we know that, we'll put 20 kg times ms back there. Okay. Now, we know that 4 times 4.5 will give us the momentum. So let me do that real quick. Is 18 kilograms times meters per second. We know that the momentums have to add together to get 20. So 20 minus 18 is 2 kilograms per meters per second. Now, because we know that this times this equals this, we can use that to divide. So basically, if we know that blank times 3.2 is equal to 2, we can basically get x by itself by dividing 3.2 on both sides, right? So 2 divided by 3.2 will give us 0.625, and that will be your mass. Another way you could do this is by using the formula that he gave you. So the formula at the beginning, remember, was this. So the mass 1, velocity 1 initially, plus mass 2, velocity 2 initially equals mass 1, velocity 1 finally, plus mass 2, velocity 2 finally, okay? So we know that our mass 1 is 4 kilograms times the velocity, which is 5 meters per second, plus the mass 2, which is x, we don't know the mass, times velocity 2 initially, which was 0 meters per second, equals mass 1, 4 kilograms, times velocity finally at the end, so 4.5, plus mass 2, which we don't know, times velocity 2, which is 3.2 at the end. So then 4 times 5, 20 kilograms times meters per second, plus anything times 0 is 0, equals 4 times 4.5, 18, plus x times 3.2, which you can also just write as 3.2x. Now 20 plus 0 is 20. So 20 equals 18 plus 3.2x. To get the x by itself, you would, because this is a plus sign and this is a plus sign, we have to do the opposite of what the plus sign is. So it would be minus 18 on both sides, which gives us, oh my goodness, which gives us 2 equals 3.2x. So to get the x by itself, we divide by 3.2 on both sides to get whatever our number was, 0.06 whatever. So you could do it the math way or you could do it the chart way. It is up to you.